The slope-intercept form of a line equation is the most important equation on the ACT. Shows up in geometry, of course, but you also see it a lot in algebra, making an equation in other places. You got to know it. You got to be comfortable with it. What I really want to express to you is that there are just two parts to it. There's the slope and then there's the y-intercept. M is always used to denote the slope, and B is the y-intercept. It's the constant. Slope is a multiple, is multiplied. B is added or subtracted. So that's all there is to it. Lines are lines are lines are lines. They're straight. They go on forever. They never change direction. They're very constant. The smaller the positive slope or negative slope, the more gradual the line is. Negative slopes, steep slopes, right? Positive y-intercept, positive slope, positive y-intercept, negative slope. 0 maybe, y-intercept, positive slope, negative y-intercept, positive slope. You should know all that. And if you're not as keen on that as you ought to be, or you just feel like it's been a long time, or you never liked it to begin with, please take a look at the book. I cover this in pretty good detail. There's tons of pictures, and it'll walk you through a lot of the stuff that I don't really want to go over too much in a video, because I want to focus on problems that are tougher, I guess, is a way to say that. So 2 parts, only 2 parts, and that's really what you got to know. Just keep that in mind. Like, if you keep that in mind, you'll do okay on this. Now let's look at what we've got here. A line passes through points 3, 1, and 5, 3. What is the equation of the line? Okay. So 3, 1, x goes first. 5, 3. So it's got a little bit of a slope to it, a little positive slope. And it will look kind of like this. Now, if they describe a diagram, and this is describing a diagram, draw it. Draw it. What I would do on this problem is mark off. You can probably mark all the way down to where at least you can test and see if it works. So let's go ahead and take a look at it. Y equals 2x. Well, it looks like we're going to have a negative slope. So, or excuse me, a negative y-intercept. Right, we're pretty much going to have to. So I would mark that off. If you don't see that, that's fine. Y equals x plus 2. Well, certainly going to have a y-intercept that's less than 2 because we're already here at 1, so that one's gone. Y equals negative x. Well, this has a positive slope, so that one's gone. Y equals x minus 2. That's promising, right? Negative y-intercept, kind of thinking that's maybe what we need. Y equals negative 2x. That's out. Negative slope. And the line's going up. You know, it's rising from left to right. So I would say it's D. That's simple. Mark through it. If you want confirmation, there's a couple ways to do that. You could say, well, I could plug in both points, right? I could plug in 3, 1, plug in 3 for where x is, and see if it spits out 1. But you have to do it on both of them, because it may work on one and not on the other. Then plug in 5, 3. Plug in 5 for x, subtract 2, you get 3. So it works perfectly. So that kind of segues into the second way to solve these. If you're going to solve it by plugging in the points, please try to mark off first, because you will save yourself a lot of time. And what I've noticed about people that try to plug in points or anything like that on all the answer choices, they typically make a mistake. They're not typically, but pretty often they make a mistake. Some sort of calculation error, conceptual error. They combine two answer choices in a weird way or something. So look at your answer choices. Have a little conversation with them. Drop my pen cap. Have a little conversation with them before you start plugging in the points. So one way to solve, mark off, which will get you, if not home, almost all the way there. Second way to solve, plug in points. Third way to solve, you can actually find the equation. So the third way to solve will be to find the slope and then plug in the points, because right now we have 1, 2, 3, 4 variables. I could try plugging in a point first. I could say, well, when y is 1, m times 3 plus b is equal to 1, but I still have a problem, right? There's two variables, one equation, can't do that. Check out systems of equations if you have a question on that. Can't do that. So what I can do, or you actually could solve it with system by doing that with the second point if you really wanted to. But what I can do is find the slope and plug that in for m. So this is an important thing to remember. Slope m is equal to rise over run. And how do you find that? Well, typically it's denoted this way. y2 minus y1 over x2 minus x1. That works just fine, right? What I'm going to do essentially is I'm going to subtract the y values. I'm just going to do it in such a way that I don't have a lot of negatives. And I got to make sure that whatever I started with, so I started with the 3, so the 5 goes with the 3. Since the 3 led on top, the 5 has to lead on the bottom. And that's going to give me 2 over 2, and my slope is 1. So now I can plug in 1 here, right? And I can solve for b. So 1 equals 3 plus b, subtract 3, negative 2 equals b. So your equation this way would be y equals 1x, or just x, minus 2. All there is to it. Now, there are several different kinds of linear equation problems. This is one I think is on the harder end, to be honest with you. And I think it tests a lot of the skills you'll need. Just because you can solve it in different ways and you can expose yourself. Do check out the material, though. There's lots of practice in there. And really throughout the ACT, see if you can start identifying times when you're actually using fixed plus variable, right? Fixed plus variable, that's what a linear equation is. So check this out. Work on it in the book. The next video on lines is midpoint and distance. Less important topic. Obviously, this is a key skill, but midpoint and distance show up on almost every test.